Good morning and warm welcome to all the viewers. This is Metro PABSON's teaching learning program and I am Manish Ghimire, teacher representative, science subject. Today I am going to teach you balanced chemical reaction, the topic from chemistry of class 10. So here I have written information obtained from balanced chemical reaction. Yesterday we discussed well about what is balanced chemical reaction and what makes or what are the ideas that reactions should be balanced, and would we add coefficient or not, what kind of coefficients can be added, we are capable of degrading the molecular structure or not. These were the informations about how to balance chemical reaction yesterday. So today I will be continuing it. What are the informations that we get from balanced chemical reaction? Since it is better than skeleton chemical reaction in terms of information it provides, what are these information? Let us see here. Actually, this is one of the chemical reaction which is known mostly with Haber's process. Here nitrogen molecule and hydrogen molecule react together under some supplied conditions which I will be explaining soon. The ammonia is then formed. In this process you can see here, this is ammonia, this is nitrogen molecule, this is hydrogen molecule. Here I have balanced chemical reactions already. This is one molecule of nitrogen, this is 3 molecule of nitrogen, and the result is 2 molecule of ammonia gas. In this process actually we need some conditions to be applied, otherwise this reaction does not take place. This condition, pressure is needed, temperature at least up to 500 degrees Celsius is needed, pressure at around 200 to 600 atmosphere is needed. Similarly, catalyst like iron powder and molybdenum as a promoter is needed. This is how this reaction takes place. But here we are going to focus about what are the informations that we get from balanced chemical reaction. Let me explain. The very first, from balanced chemical reactions we come to know the name and symbol of reactants and products. Look, this nitrogen molecule, this hydrogen molecule, and molecular symbol of nitrogen is N2, whereas that of molecular symbol of hydrogen, I mean to say, that is H2. Likewise, molecular symbol of ammonia is NH3. In this way we come to know about the names and symbol of reactant and product molecules. Likewise, another information that we can get from here, see, we come to know the total number of atoms or molecules of reactant and products. See, 1 molecule of nitrogen is needed to produce 2 molecules of ammonia gas. In this process, 3 molecules of hydrogen gas is required. I mean to say 2 atoms of nitrogen and 6 atoms of hydrogen are at least needed to produce 2 molecule of ammonia gas. But make sure this condition is always needed, otherwise it is not possible that reaction takes place. Similarly, other information, look, we can get information about the ratio of molecular weight. The molecular weight of nitrogen molecule here is 28, because atomic weight of nitrogen is 40. Here 2 atoms of nitrogen, so together molecular weight is 28. Here molecular weight of 3 molecules of hydrogen together becomes 6. You must know that, because atomic weight of hydrogen is 1. Molecular weight of 1 hydrogen molecule is 2. Therefore, molecular weight of 3 hydrogen molecule is 6. Similarly, molecular weight of 2 molecules of ammonia gas which is formed here must be 34. In this way we come to know, we come to find the ratio of molecular weight of reactants and product molecules. Similarly, we get one more information from balanced chemical reaction, and that is, see, we can find out the type of chemical reaction. Looking at this, we can say, since two different molecules, reactant molecules, are combined to form a single product molecule, it is combination type of chemical reaction, or we can say addition type of chemical reaction or synthesis chemical reaction. So, whatever I have explained, all I have presented there in screen. Have a look on the screen, please. In screen, all these things are written in summary. Please have a look on the screen. There is written everything about all this. There is a little mistake in the table, you can find it out. Chemical equation is not balanced there. Actually, nitrogen, one molecule of nitrogen is there, fine, but hydrogen number is not balanced there. So, I am awareing you to add number 3 in front of hydrogen molecule, so that reaction would be balanced. Otherwise, everything is fine there. This table summarizes the information that we get from balanced chemical equation. Please have a look there properly, and if you need to copy it down in your copy, please do it. Okay, there I have portrayed the next screen. There is a difference plotted between balanced chemical equation and skeleton chemical equation. I have said yesterday well about what is skeleton chemical equation and what is balanced chemical equation. Skeleton means the type of chemical equation which is not balanced. There you can see, and balanced means what? The number of atoms of each element in the reactants and products are balanced. The first difference is about definition. There you can find it out in your screen. Similarly, there is a second difference plotted. Balanced chemical equation gives a detail about reactants, product, the ratios between them and the direction of the reaction, whereas these informations are not fully found from skeleton chemical equation. Similarly, stoichiometric coefficient, information about stoichiometric coefficient means what are the numbers that should be added in front of molecular formula of molecules in balanced chemical reaction can be well found, whereas that is not possible to be obtained from skeleton chemical equation. Fine, this is the difference about balanced chemical reaction and skeleton chemical reaction. There now is a turn to study about what are the limitations of balanced chemical equation. You may think balanced chemical equation is very fine form of equation. It is not absolutely true. Still there are some problems, still there are some limitation, some demerits are still there in balanced chemical equation. To make you aware of this, let me take one example. Even though chemical equation is rightly balanced, you cannot find out the physical state of reactants and product molecule. For example, in this chemical reaction, see N2 plus H2 NH3. You can balance it, no problem, you can well balance it. Look, it is completely balanced. The number of atoms of each molecule in reactant side and product side are correctly balanced. But what is the problem here? The problem here is you cannot say whether this is in gaseous state or liquid state or solid state. You cannot even say about hydrogen also whether it is in gas, solid or liquid state. Likewise, the problem exists same with this product also. So, there are some limitations of balanced chemical reaction. So, some modification in chemical reaction has been introduced that we will be focusing later. Now, have a look on the screen please. Then the screen written, let me just read it out. Even the chemical equation which is balanced does not provide the following information. Number 1, there is written physical state of reactant and product molecules. I just explained this. Okay, let me take one more example on the half of this information. See this chemical reaction here, AgNO3 plus NaCl. The result would be AgCl plus NaNO3. Look at this chemical reaction. This chemical reaction is balanced or not? Let us count. The number of atoms in the reactant side, I mean to say of silver, is 1, here also 1, it is balanced. 1, 1. Here number of nitrogen 1, here number of nitrogen 1, it is also balanced. Here total oxygens is 3, oxygens number 3, here oxygen also 3, it is also perfect. Sodium number, I mean to say number of atoms, number of sodium atom is 1 here, here is also 1, fine. Here number of chlorine atom is 1, here is also 1, fine. This is automatically balanced. But what are the information that it lacks? Let us find out. Actually, you cannot say what is the state, physical state of this silver nitrate compound. Can you find it out? Of course you cannot. It is because there is written nothing. There is neither written solid, nor written aqueous state, not written gaseous symbol. Nothing is written, so you cannot say anything about the state, physical state. Actually, to make this reaction occur, I mean to say, to let these two chemical substances react together, we must use solution form of these two chemical substances. We must bring aqueous solution of silver nitrate and sodium chloride. They react together only in their aqueous state. In the solution state only they react together. Otherwise their reaction does not occur. So this is the problem with balanced chemical equation. It does not state the physical form of them. So sometimes we cannot make reaction occur just looking at balanced chemical reaction. Look at this. This also in aqueous form, but this is formed in solid state. White precipitate of silver chloride is formed when silver nitrate and sodium chloride react together. So on writing yes as a subscript down the silver chloride, we can come to know what is the state of silver chloride formed. But this information is missing in balanced chemical equation. So chemical equations have been modified in different way actually. Keep focusing on screen. There the next point written about the problem of balanced chemical equation is concentration of the reactant molecules. See, concentration of the reactant molecules. Let me explain this. Actually, even the balanced chemical equation does not say whether the chemical used there is fully concentrated or diluted. Diluted means, let me just show you one example. When sodium is reacted with HCl, it forms sodium chloride along with hydrogen gas. Look at this. In this case, equation is not balanced. We must balance the number of chlorine atoms. here 2 chlorine atoms, so better we put 2 here. On adding 2, number of hydrogen become 2, here also number of hydrogen 2 is fine, number of sodium also 1, number of sodium also 1 is fine. Now it is balanced chemical equation. But tell me, can you say, looking at this, whether HCl, I mean to say hydrochloric acid used here is concentrated? Can you say? Or it is diluted? I mean to say, can you say hydrochloric acid dilute acid or concentrated? It's quite impossible to say, just looking at this balanced form of equation. So this is the problem with this. In fact, this reaction occurs, hydrogen gas is formed only when acid used is dilute. Otherwise, it is not possible. Acid used must be dilute. With concentrated acid, the result may not be same. So chemical equations should be modified in such a way that even concentration of reactant molecules should be mentioned, and that is what exactly done in modified chemical equation. So the next point there, see in the screen, the third one there is conditions, heat, light, pressure, catalyst, etc. required for chemical reactions to take place. Look at the same chemical reaction here. Actually, in this chemical reaction, all the number of atoms of each elements in both the sides are rightly balanced. It is balanced chemical reaction. But under what condition does this reaction occur is not mentioned. Let me write one more example here. CaCO3, it is calcium carbonate. When calcium carbonate is decomposed, it breaks down into 2 different compounds. It is calcium oxide and carbon dioxide gas. Since it is gas, the arrow is given up. It indicates the formed form is carbon dioxide gas. So this is calcium carbonate compound. But look at this. Do you think reaction is so easy and it occurs in easier way, like I have written here? Only on bringing calcium carbonate and putting here somewhere on the surface or chemical lab, the calcium carbonate would break down. Is that easy? Of course not. It's not that easy. It requires some condition which is not mentioned here, and this is the problem. This is the problem with balanced chemical equation. It lacks the information about the condition that chemical reagents need to break down into its components. See, calcium carbonate breaks down only when it is heated at about 250 degrees Celsius. Calcium carbonate decomposes into calcium oxide and carbon dioxide only under the supply of heat, which is not shown in balanced chemical equation. This is the problem. Moreover, it requires some more catalyst like MnO2. It accelerates the rate at which it decomposes. So balanced chemical equation does not give information about what are the catalysts needed to make reaction takes place faster and under what condition reaction takes place. Whether chemical reaction need heat or the supply of light or catalyst or promoter, these informations are not found there in balanced chemical equation. Likewise, the next point is there, the rate of chemical reaction. Balanced chemical equation does not indicate what is the rate, at what rate calcium carbonate decomposes into calcium oxide and carbon dioxide gas. So it lacks the information about rate of chemical reaction also, and one more, it does not indicate fully about the specific type sometime. That is also a problem with balanced chemical reaction. So have a look on the next screen. Here there is next topic, that is about reversibility and irreversibility of chemical reaction. Reversible chemical reaction. Reversible chemical reaction. Reversible, look, I think this word is enough to make you understand in an easier way. Reversible means which occurs forward as well as backward. The type of chemical reaction which takes place in both the direction. I mean to say, when reactants combine together to form product, the product also possesses an ability to break down back into the reactant molecules. This is what we call reversible chemical reaction. Look at the example here. H2 plus I2, it forms HI, hydrogen iodide. Look at this chemical reaction. Number of hydrogen molecule here 1, iodine molecule 1. Here we must balance it by adding the coefficient 2. 2 molecules of hydrogen iodide is formed. In this chemical reaction, this hydrogen iodide may break down back into the reactant molecules again. That is why this chemical reaction is reversible chemical reaction. And let me make you understand how the arrow is used here. Actually, this is double way arrow. This double way arrow makes you know this is reversible in nature. Similarly, this reaction, look at here, N2 plus H2, the most famous Haber's process. H2 plus N2, it forms NH3. Look at this chemical reaction. This is also reversible chemical reaction because nitrogen and hydrogen combined to form ammonia gas, whereas ammonia gas on the release of condition provided here, means I mean to say when this condition provided here are all withdrawn, then the formed ammonia gas breaks immediately back into the reactant molecule, the nitrogen and hydrogen gas. So this also occurs in both the direction, the forward direction and the backward direction. So this is reversible in nature. Likewise, the next you can see in the screen, there is given one more example down and is explained well in this chemical reaction. I am reading that black highlighted font. In this chemical reaction, hydrogen and iodine on heating forms hydrogen iodide. When hydrogen iodide is heated in a closed vessel, it forms back the hydrogen and iodine. Thus, it is reversible reaction. Anyway, next type is irreversible chemical reaction. Okay, irreversible chemical reaction. Let us focus on irreversible topic. Irreversible means cannot be reversed back. The type of chemical reactions which occurs in only one direction, means which does not take place in forward and backward at the same time. Once product is formed, that is final. That product cannot break down, cannot be broken down back into the reactant molecules. Let me take just an example here. CaCO3. I said you many times, this is calcium carbonate. When it is decomposed or heated at about 250 degrees Celsius, it forms two compounds, product molecule, I mean to say. One is calcium oxide and one is carbon dioxide gas. Look at this process. Once calcium carbonate is heated and broken down, breaks down, it breaks down into two product molecules. These product molecules cannot combine back to give the same product. This is irreversible chemical reaction. Likewise, one more example I can show you. Look at this reaction KClO3. This is potassium chlorate. When it is heated at around same temperature, it forms potassium chloride plus oxygen. When it is balanced, it forms like this. In this case, potassium chloride and oxygen does not combine back to give potassium chlorate back. Means this reaction does not occur in reverse direction. It cannot be reversed back, so it is irreversible in nature. So, in screen there is shown one more example. You can see just down, have a look there. Sodium on reacting with water, sodium on reacting with water, it forms sodium hydroxide and hydrogen gas. This reaction is also irreversible chemical reaction. Now, next type, exothermic and endothermic chemical reaction. Just there is written definition along with examples. I think that makes you quite clear about exothermic and endothermic. It's nothing but exothermic means that type of chemical reaction in which heat is evolved automatically when reaction occurs. Look at the first reaction in the screen. Carbon plus oxygen, when reacted together, it forms carbon dioxide gas when the supply of oxygen is sufficient. In this process, heat is evolved automatically, means this reaction releases heat. So, it is exothermic in nature. Likewise, one more example is given down. When carbon is reacted with hydrogen gas, it forms methane. Along with the production of heat energy, that is why it is also called an exothermic chemical reaction. Likewise, endothermic means just down there, the next topic. Endothermic is just opposite of exothermic chemical reaction. In endothermic chemical reaction, you need to supply some amount of heat energy which would break down the given reactant into product molecules. There is an example, 2KClO3 on providing heat breaks down into potassium chloride and oxygen molecule. That is why it is called endothermic chemical reaction. In endothermic, you need to provide heat to make a reaction occur, whereas in exothermic, heat is automatically evolved, it is automatically released out of chemical reaction. So, since I have come to the end of today's episode, I will be explaining this as a last topic for today from chemistry, of course. It is all about what are the factors that affect chemical reaction. There are some points listed, there are some factors listed which affect chemical reaction, which affect the rate of chemical reaction. The very first there is heat. Heat affect the rate of chemical reaction. How does heat affect? Let me explain. Actually, when heat is supplied to the reactant molecules, they gain kinetic energy. They gain vibrational energy. They collide more frequently. They come in contact more frequently. Hence, products are formed at higher rate. Means the supply of heat not just initiate chemical reaction, but increases the rate of chemical reaction also. So, some chemical reagents are like they do not break down without the supply of heat. That is why it plays great role in occurring the chemical reaction. Likewise, the next point is light. See, let me give example to just explain what are some examples of chemical reaction that initiates with the supply of heat. CaCO3. Look at here, the same reaction, it needs heat at around 250 degrees Celsius. It forms CaO plus CO2. Likewise, another example you can see, nitrogen and hydrogen react only when temperature is around 500 degrees Celsius. These are some examples which does not occur without the supply of heat, of course. Look at the light. Light also initiates some chemical reaction. For example, when hydrogen and chlorine are needed to be reacted together to form hydrochloric acid, it is must to supply light there. Without the presence of light, they too do not react together to form hydrochloric acid. The same thing happens when silver bromide is to be broken down. Look at this silver bromide. It breaks down into silver and bromine only when light is present. That is why light also affects chemical reaction. Some chemical reaction cannot occur without light, and these are some examples, of course. One more thing, let me explain about pressure. What does pressure do in chemical reaction? Actually, pressure brings molecule together. Pressure incites molecule to have a collision. Pressure increases the density of reactant molecules by decreasing the area. In this process, collision is most frequent, and hence reactant molecules changes into product molecules. So, pressure is also very important for chemical reaction to occur. Look at the example here. In this chemical reaction, N2 plus S2 does not react together until you supply 200 to 600 atmospheric pressure. So, pressure is also needed for some chemical reaction to occur. Without pressure, chemical reaction does not take place. Catalyst, the next factor that affect chemical reaction. See, catalyst. Catalyst means those chemical substances which does not take part in chemical reaction but cause reactants to react faster. It accelerates the rate of formation of product molecules. Let me take one example of hydrogen peroxide. Hydrogen peroxide breaks down into water and oxygen gas. To balance it, see here, I think it is balanced fine. 2 into 2, 4 hydrogen atom, 2 into 2, 4 hydrogen atom, fine. 2 into 2, 4 oxygen atom, here 2 and here 2, fine, it is balanced. Look at this chemical reaction. This chemical reaction need catalyst anyhow, otherwise it is very slow chemical reaction. In this chemical reaction, you need to supply manganese dioxide, which acts as a positive catalyst and increases the rate of formation of oxygen gas. In this Haber's process also, in this reaction also, see, in this reaction also, without iron as a catalyst, reaction is very slow. So, catalyst also plays great role to make reaction occur, to make reactant change into product faster. Similarly, solution state, state of reactant also matters. State of reactant is also one of the factors that may affect the rate of chemical reaction. See the example here. Actually, I already plotted this reaction before. AgNO3 plus NaCl, AgCl plus NaNO3. In this chemical reaction, this and this molecule, I mean compound, react only when their aqueous solution is reacted together. I mean to say, they react only under their aqueous state. They do not react when their solid form is brought together and tried to be reacted. It's impossible. In fact, in their aqueous state, they undergo ionization, and the opposite ions are exchanged to make a product molecules. So, what are the states of reactant molecules also affect chemical reaction. Contact is always must, you know that every chemical reaction, more than 99% of chemical reaction occur when there is physical contact between reactant molecules. More the physical contact, more is the ability to form product. This enhances the rate of chemical reactions too. And electricity, of course, look at here once, electricity is also needed for some chemical reaction to take place. For example, electrolysis of water. When water is electrolyzed by the supply of electric current, it breaks down into two different gases, hydrogen gas and oxygen gas. In this case, supply of electricity is must. In most of the ionization reaction, electricity, supply of electricity is needed, whereas some other reaction in which reactants undergo ionization is possible only when their aqueous solution is prepared. Anyway, this is all for today. Thank you for your passion and presence that you remained throughout this time with me. Have a wonderful day. We will meet again tomorrow. Bye-bye, and again, bye-bye.